Discover NEXT, the studio for facades and design. NEXT is the platform for innovation in the field of building envelopes, for inspiration, information, and communication. Initiated by WICONA, with leading industry experts as NEXT partners. NEXT is a unique concept which is constantly evolving and bringing the future of cities to life.
Action.
I think we should start now, is it? Yes. Yeah. It's a bit weird. We've been talking since, what, 5 minutes, and they're saying, no, it's going to start, it's going to start. It's not starting. Now it starts.
Now it starts. Warm welcome to all of you.
We have to announce that the 5th International NEXT Facade Session. And the two of us, we invented this setup. We said it should be next generation. We met last time here in Frankfurt as well, and it felt like...
The elder ones.
We're old, we're grey-haired, and we have to get the new ones in, the new generation. And the briefing was, you have to pitch us. You have to somehow show what, say, where's the spirit? Looking there, because there are two of them.
So we brought the young ones today to take you on a ride into fresh technology, new ideas and all that. It will be obviously very inspiring. Allow me to introduce Uli to you. Ulrich Knaack, well known in our industry, studied architecture in construction and constructive glass build. Actually,
his paper is here.
His paper is here. Took his career 5 years onwards with LKW, a very interesting, fabulous architectural firm, and moved further into universities. He's the 3D university specialist working in Detmold, Delft and Darmstadt by living in Düsseldorf, so everything is D around you, and it's a privilege to be here with you. So,
I have similar jokes about him.
Oh, ouch.
No, ouch. Lars Anders did an apprenticeship as craftsman, Bauschlosser.
Yeah.
And then did a civil engineering study, worked in his family's company, and joined Priedemann in 2002 as employee number 2.
No, 6.
No, 6, sorry. 6.
Number 6. Number 6.
How much are you now?
156.
156, actually. And that makes it clear. Yep. Then the boost starts as an activity. However. Right, session today. First, we learned we have about 700 streaming, which is an enormous number, which puts a lot of pressure to the speakers. Speakers Jens Böke, Gertjan Peters, Dominique, Vosmaer, and Denz. This order, 2 of them here in Frankfurt, 2 of them in the Netherlands. Due to travel restriction, they're going to be digital with us.
We got tested, by the way, so we can stand close.
Yes, we all tested here,
so
this environment
COVID is not an issue.
So that should work.
Yep, and I may introduce the first speaker. It is Jens Böke from Priedemann. He joined us recently, a young, fresh talent, carrying all our hopes for the future. Jens will introduce to you Thinking Skins, a very interesting term, obvious, and will show you a fabulous presentation about cyber-physical systems and all the things he have in mind. So be curious, stay awake, listen, and be ready.
Yeah, hello everyone, and thank you first of all, Lars, for the kind introduction. Also, thank you for having me here today, which is quite special for me as in these days I'm not used that much anymore to being physically present at an event. So I hope take it as a signal that hopefully in close future we will have more of these kind of events again after hopefully overcoming the corona pandemic. What I'm going to introduce to you today is my doctoral research project, which was called Thinking Skins, Cyber-Physical Systems as Foundation for Intelligent Adaptive Facades. And it was my doctoral research project that I did at the TU Delft, promoted by Professor Ulrich Knaack, and also by Marco Hermerling from the Technical University in Cologne. And actually, I would like to take you with me on a small journey through my project and also the experiences I had here. So when I started, my background is, first I wanted to say, is the one of an architect. And quite early in my studies, I realized my great fascination for computational design tools, and I also had a strong belief that computers and computation can have a big positive impact on how we design buildings, but also how we operate buildings. This was a strong belief that I brought into this project already, but actually, to be honest, I was overwhelmed by all these new terms and also keywords that were introduced alongside with the term of digitalization, which were quite new for me during the official start in 2014. And at that time, I was employed as a research associate at the Ostwestfalen University of Applied Sciences. And there also was one unit focusing on Industry 4.0. It was called the ITS OWL. And by coming across this, I started to be curious and wanted really to know what is Industry 4.0 about. And what I had to learn is that this addresses the fourth industrial revolution. And after the introduction of mechanics, mass production, mechatronics, now cyber-physical systems are the main driver of what they develop here as smart factories. So this directly led me to the questions, what are cyber-physical systems? Another keyword and term. Cyber-physical systems, there is no universal definition for cyber-physical systems today. This is because there are so many application fields, and the understanding of a cyber-physical system differs from application to application. Instead, today we use characteristics to describe such systems. They all can be described by the close integration of the physical devices and their digital control. And one key aspect, which is also visible here, is the embedding of the devices. It means that we no longer have a central control, but we start integrating computing capacities into the devices, so we equip them with their individual intelligence, and we enable them to communicate with other and to cooperate towards a common production objective. And why does the industry do this? Because they expect a great increase of flexibility in production processes, but also in the productivity, so a greater performance of their processes. This seemed very interesting for me. And now coming to the actual topic of facades, we already know that automation is nothing really new for the facade industry. We, of course, automate many facades today. We integrate sensors, apply them to the systems. We have controllers, but also actuators that then actuate, for instance, adaptive facades. And following Jules Maloney in his estimation, with an existing input system, a processing system, and an output system, we can understand facades as mechatronic systems, which directly refers to the Industry 3.0 understanding. So it's centralized. Most of the facades today have a centralized and hierarchical control concept. But this is the background I saw, which led me to this research question: how can cyber-physical systems be applied to facades in order to enable coordinated adaptations of networked individual facade functions? In this way of thinking, it means that the automated facade functions form a network. They communicate with each other and increase the performance by better mediating between the external boundary conditions and the user requirements that might also change in front of different user demands that might change. So it's actually about the shift from centralized and hierarchically controlled strategies in the facade towards a more decentralized control concept. In order to be able to answer my question, I conducted several research investigations. They all were published as individual chapters and in the end as individual journal articles, and in the end formed the chapters for my final dissertation book. To give you a better understanding what I actually did in each of the investigations, I will quickly dive into them. And the first one was better understanding, to identify all the relevant knowledge fields. The title of the paper here was State of the Art of Intelligent Building Envelopes in the Context of Intelligent Technical Systems. So I compared what happens in the Industry 4.0 to what is automation or what happens in the facade industry to get a common understanding and to be able to transfer the technology between both domains. In the second investigation, I asked myself, what are the possible facade functions that are due to their possible automation and possible adaptivity and impact on the performance of the facade can be considered as players in such a cyber-physical facade system. And so I started to investigate which functions can be automated and have a performance impact. Second, how can we evaluate these functions within the system? And this is when I started to develop this superposition matrix, which overlays the facade functions that I was able to identify with possible characteristics of their adaptive implementation. In the next step, I wanted to know what are the current conditions in building practice. And therefore, I did this case study analysis, investigating different German projects. And what you can see on the right side in the diagram is that only some functions are not even considered. They are not implemented in the projects I investigated. Some of them are considered, but they are actually not automated. So these are static functions. It's the black ones. Then only the blue functions that you can see here, they are at the same time automated and adaptive together, so implemented like that in the function. And here I saw that this might be very promising to test them, because they already are automated, for a possible implementation of a cyber-physical system. So how to demonstrate that actually a cyber-physical facade system is possible? And this is when I decided to develop a prototype, which should be a demonstrator about adaptive negotiation and also the communication within the system. And I picked the most promising that I just clarified, these functions that were for me quite promising, like the sun shading, the ventilation, and the heating and cooling. You can also see here in the center there are 6 times the solar shading function. We have mechanical ventilation on the top, then 2 times natural ventilation and heating and cooling, which is demonstrated by blue or red illumination. What I wanted to demonstrate with this prototype is that key characteristics, which I mentioned in the beginning of the presentation, can also be implemented in a facade system. So this first one is the embedding of the facade functions. So to integrate controllers into each of the functions to make them independently intelligent. Second, the decentralized organization, which also comes to the next point. They have to be able to communicate with each other and to share information. And then what I added, which I didn't mention in the beginning, it was also the idea of a digital twin. So something that helped me to monitor and to also demonstrate the cyber side of this cyber-physical system, while this represents more as a physical prototype, the physical aspects. This is also the main idea. And what you can see here is that working at a university, I had a limited amount of budget. And I started to use standard and simple products and equip them with automation technologies. This means that I used these Venetian blinds. I just disassembled them and added a servo motor, which then helps to do the opening rotation of the elements. At the same time, I added this stepper motor, which just pulls a wire to do the opening and lowering. It was not intended that the prototype works actually physically. It was more understood as a demonstrator, a visualization tool that helps to understand the process and the communication within the system. So this is the first function that I developed like this. You can also see I used some of my skills in digital fabrication to do my own devices, like a 3D printed wheel that then winds up the wires for the opening and closing. So in the end, you see the result on the right. This was the sun shading device. A bit more complex complexity came up when I also had to provide these microcontrollers. I had to learn soldering and use these elements, these small microcontrollers, which were for me quite useful because they come with a network ability. They can directly join to a wireless network. So I used these elements, and every of the functions that you just saw, each module is equipped with one independent intelligence. What it does it also has all the sensors necessary installed that helps to perform the functions. So each function is an independent feedback loop, collecting all the relevant information, then processes this information, and brings it then to a reaction of the system. This strategy I applied to all the functions that I covered in my prototype. What you see here is the development of the ventilation system, which is both covered by natural ventilation. Here I fab-labbed again, or digitally fabricated a gear system on our laser cut in the university, and I also 3D printed these small devices here, assembled them. Everything was considered to be plug and play. This was also the reason for me to start learning soldering, because this can easily be disassembled, and therefore for me it was quite important to make sure that if something fails in this more high-tech solution, that I am able to just replace broken devices. The other ventilation is the mechanical ventilation. Again, I used the standard product, which is just a computer fan, and you can say I tuned it, hacked it. It was then possible with a relay to switch it on, off, or also change the speed by PWN interpolation. So this, after finishing all these functions, I had some kind of a playground now with different working functions that I could start playing with the communication with. What you can see here is next to the realized functions on the right side. By the way, I didn't expect so many LEDs placed into these devices, so when it was finished around Christmas, I was just wondering, it saved me the Christmas here, and there was a lot of illumination. This is no photo art, it just came from the pictures that I took because of the illumination here. What you see is the realized prototype, but also here the communication comes into play. So I installed a router and the server, which is the platform for communication within the system, and also I added the power supply. Up to 5 volts, I was quite fine. This added then the 220 volts, where I felt a bit more in danger. I could talk much more about how I realized this prototype. Maybe it's easiest to just show it working, and this is why I show this video. What you can see is just the individual functions, like the shading system that opens, closes. I also installed displays, which helped me to evaluate the measured sensor data. You see all the technical stuff integrated here, and I was quite happy that all the functions directly worked. And the back you also see the sensors, the light sensor, a distance sensor, which could also measure a person that approaches the facade. Here you see again, like all my switches, the power supply, and in the background it's the heating and cooling function, which is demonstrated by the blue and the red LED illumination. The next function here is the gear system for the natural ventilation. Again, you see the applied microcontroller as a local control. The sensors installed is a temperature and humidity sensor and also a CO2 sensor, and it could visualize 3 states like open, closed, and half open. And last but not least, the mechanical ventilation. I just explained also like different speeds and on and off were possible with this function. What you just saw is the feedback loops on the lower control level. So it happens locally based on within each function based on sensor data. More interesting it became when communication came into play. This means that there is a second higher control layer where all these aspects of the prototype communicate with each other. And again, I could explain a lot about MQTT, machine-to-machine communication, but maybe it's just easier to demonstrate what happens here. Each LED that you see here blinking means that the message is sent from one of the modules or received. So all these functions communicate with each other, but also with the digital representation, the digital twin, which receives the information. And they communicate, and also the user interface was an important aspect because it enables to interact with the system and to validate what was going on. How to evaluate the system in the end? I mean, of course, I saw that some things were working, but to evaluate the potential of communication, I did these small scenarios that I imagined. Again, it was not about the physical performance, but more about to visualize how the communication could help in a facade, which is in this place, or in this situation, the natural ventilation has also a noise acoustic sensor. It receives a disruption, and it knows now, okay, I should close the natural ventilation. But it doesn't not only close, it also tells the mechanical ventilation that this is the case and hands over the tasks. And after a while, when the signal is lost, it takes the job back. So this was just one scenario to prove, okay, these two modules, these functions can communicate, they can talk and share information throughout the system. I did this with in total 5 scenarios. I will just show one more to understand, and what I called it community decisions, because what you see here is different instances of the sun shading module. They all receive the information that there is some light and they should actually provide sun shading. Just one function is tricked with some tape, so it gets wrong information. And what happens on the higher control level is that all the others say, you are somehow wrong, you received the wrong information, and they override what's happening in this local control level. So again, they talk, these functions communicate, and in the cloud, decisions are made that can also help to get more flexibility within the system. So what does this all tell me in the end? And this is already when I come a bit to my conclusion. First, I would say that cyber-physical systems are technically feasible. This is what I actually also wanted to demonstrate with my prototype. But I see special potentials in the cooperations between functions, which could be, on the one hand, between similar or same instances of the same functions, so different sun shadings, for instance, as we just saw it, they could help each other and inform each other, communication could take place, and this negotiation might lead to better results of an adaptive facade system, the holistic system. Then also between different facade functions, like the natural ventilation and heating system, it would be good if the heating system knows that we are just ventilating and not vanishing any energy. And also I see an impact on the robustness of such systems, because we not only have only one sensor in our system, there are many, and there are many functions and many calculations. So if one of the parts fail, the others could take over and share also the information throughout the entire system. This is only a very first step in this research direction, and I understand thinking skins the research as a conceptual framework, either for the further research, but also for the practical implementation in building practice. This is the short journey through my project, and maybe a last word. Who is interested in what I just showed, there is an open access publication, and Thinking Skins can be downloaded as a book from TU Delft directly.
The typical library thing. Yes, applause.
Wow.
This is a live applause. There are about 8 people in total in the room, so it's a limited group, all tested. Yep. That's clear, but it's actually nice to have an applause, even in a digital situation. So, well done.
Well done, Jens.
As an architect, how would I use it?
Sorry?
As an architect, how would I use it? Okay, I want thinking skin. That's cool. How would I use it? You're now in a facade consulting company. Make me my skin thinking.
Invest.
The first answer, very good, very good.
I think it takes money to further develop this.
Technically, that's say the researcher speaking.
But we all go through these sustainable solutions where we suffer in the end of the day that we have to provide a manual how it should be used. In any client meeting, you discuss if an end user can override the sustainable technology we create. And what we see as an amazing potential is that there's a communication bridge to bring all these interests together, and in the background run systems who understand what is the user's interest, what is the interest, or what this solution should provide and add. And I just like the communication between natural ventilation and the mechanical systems, and that makes so much sense that I have to say we are so proud to have that fellow with us now, and you can stay jealous.
I say unbalance him and he balances back, and that's actually the thinking part, which is should
fabulous, lovely.
Thank you.
Well done.
Right. Now we're trying to get the friends in the Netherlands in.
So we go over the border?
We go over the border. As said, no travel. So they found a place in Velp.
Yep.
There they are. The company is called ABT, and within ABT, Gertjan Peters is the facade expert. Gertjan Peters and me, we met 3/4 of a year ago, and we entirely have a digital relation. I never saw him in person. We see each other currently, let's say, every second week, for whatever reasons, but we never really physically met. So I actually don't know how tall he is.
Yeah. COVID data dating.
COVID data dating. Gertjan, you introduced yourself, but what I learned, he's getting 50, he's turning 50 in 2 days. So he's not really a young one.
But he looks young.
He looks young. Okay, give it that one. Off you go.
Enjoy.
Yes, thank you, Ulrich, for the introduction. A small correction to start with. I'm turning 49 in 2 days, but well, that's my 50th living year, we would say. So, yeah, thank you for having me today on your 5th facade session. Yes, I would like to start with my presentation. First of all, please allow to introduce myself and ABT. As you can see, my name is Gertjan Peters. I'm a facade and glass consultant with ABT, and almost for 2 years now. And previous job was at Brakel Atmos, and I almost worked there for 20 years. I had made my education in business administration, so everything I learned the last 22 years was learning on the job, and I really feel good about this way of learning. Okay, ABT, it's an engineering company. It exists since 1953. We are located in 3 different countries, Germany, Belgium, and 4 locations in the Netherlands. And we provide almost every engineering service except architecture itself. And we therefore believe very strong in this integrated design approach. That's really a characteristic of ABT and the way we work. Well, this is our organization. And as you may see, we are a bit different organized as other engineering companies. We work in knowledge groups. We have 16 of them, and all the expertise is secured in these knowledge groups. And for every project we do, it is determined what expertise is needed and who's the best person for the job. What you all can see is that there's a lot of communication between these knowledge groups. It's all these lines which are connecting these knowledge groups. And what we experience in practice is that many developments and innovation lie on the intersection, on the interfacing between these knowledge groups. So it's mostly 2 or more knowledge groups who drive innovation within ABT. Okay, today I want to take you along with me on how we do projects within ABT. And I would like to do this by showing you 3 projects. And well, what I want to tell you, what I want to show you is how we do it with an open mind and design driven. We really managed to achieve exceptional results in these projects. So always with the common goal to realize the ambition of our clients, but we do it the ABT way, as I might say. Okay, first story. First project I want to show you and I want to tell you about is the Co-Creation Center in Delft. It is located on the Green Village, which is part of the campus of the university in Delft. And you can see it as an open-air laboratory for experiments for new technologies, mainly focused on residential and the living environment. And the Co-Creation Center was one of these projects. And the challenge with this project for us was mainly that the ambitions were very high, but the budget was limited. So we were asked to think together with the client and the other companies involved for a solution to realize the ambitions within the budget. My colleague, Diana de Krom, she's a structural engineer with at ABT and also the project lead of this project. Together with the team, they came up with an idea. And this idea was to, why don't we use the glass fins, which were already in the design, but mainly for absorb the wind load on the facade. But why don't we use these fins to bear the loads of the architectural roof? Okay, a bit of a crazy idea in the beginning, but talking to other stakeholders in the project, the idea became more serious. So, within the starting points of the project, so the triple glazing and the glass fins, they elaborated this idea. And as you can see on the left detail, on the left image, you see the detail they came up with. So they integrated the triple glazed facade elements together with the glazed wind fins. Next step is how to make calculations about these structures. So they really made elaborate calculations, and they researched all the different scenarios that were possible for the loads and the structure and stuff. And I'm not a structural engineer, but I was really impressed by the schemes that I saw in the project folder. So you see the image of one of them on the right. And it turned out to be possible to execute this design. Okay, so but the calculations for itself were not enough. So Diana thought it was a very good idea to test it in practice. So together with the university, the TU in Delft, they executed these tests. And as you can see, there were quite heavy tests on the first glass fin. They executed a triple test of 12.5 tons in 3 different ways, with 1 lateral breakage, with 2. And they all succeeded. And then they come up with the second test, which was even more heavy. And the last test was with 20 tons and with complete breakage of all 3 layers of glass. So the fin was only connected with the structural interlayers. And it succeeded as well. For 10 minutes, it could bear the load of 20 tons. And that with a fin length of 5.2 meters. So quite remarkable. Okay, so calculations succeeded, the testing succeeded. So next step was production and the assembly of the elements. And here you see a few pictures of the assembling process. As you can see, quite large panes, quite heavy elements, and it had to be temporarily supported by some very light steel columns. But when every glass fin was in place, they removed it, and the architectural roof really landed on the fins, and it was quite a remarkable result. So here it is, as you see, a fully glazed facade with no steel structure in, however, and completely bearing the loads of the architectural roof. And in the end, also with some nice sustainable results, because glass has a lower CO2 footprint than steel. It's recyclable, and using only the glass really saves material in the end. So this was, this is story 1. So this shows that by looking in a different way to facades, you can come up with really nice results. Yeah, the second story. The second story is about the Naturalis Biodiversity Center, and maybe you know, maybe you don't, but it's two things. It's one thing, it's a research institute, and on the other hand, it's a natural historic museum. So it was a renovation, and they also planned a new building next to it. And what you see here is the facade of the new building. ABT was commissioned by the architect, Neutelings Riedijk Architects, to take care of the architectural design and also on the site supervision. And during this assignment, we were challenged to optimize the crown facade, as they call, and it's the white facade, as you see on the picture. My colleague Chris van der Ploeg and his team started working on this, and they used all different kinds of methods for it. They used the scale models that were available, and step by step they came to the solution that a parametric approach would be very useful for this project. So in the very beginning, they made a 3D model, as maybe you can see it on the left, and it was in AutoCAD. But soon they switched to Revit to use a better 3D model software for it. According to Chris, parametric modeling requires a different mindset. And he explained it to me in 4 steps. He says, well, first think. Second, you have to make the rules. Third, third step is coding. And if you do it right in the right way, you only have to press enter. It seems really simple. Maybe it's not. I will show you in the next few slides how it works according to Chris. So first step, think, seems logical, but sometimes it proves to be difficult in a way. So it's good to realize that the thinking process really is one of the most important steps in this parametric approach. The second one was make the rules. Make the rules is 2 things: defining geometry, but also defining the rules for the design. And as you can see in the sketch Chris made, he really analyzed this form of this shape of the facade. And after he did so, they started to code, and they used 2 software programs for it. The first one is Dynamo, and the second one is Grasshopper. And they managed to code this facade model and to link it to Revit. And after they succeeded in this, they were able to press enter. And as you can see in the left image, you can see the changes in the facade. As the values change, you see the facade appearance also change. So maybe this one goes a bit quick. So I can try to do it again. So the green values are the changes they make, and you see it in the image of the facade, what the effect is on the facade. So in this way, they could look at all kinds of scenarios for the dimensions of the facade. And they also could analyze it in a proper way and a very elaborate way. So after they succeeded in this analysis, in this parametric model, they looked for a way to communicate it with the architect, with the members of the design team. So they decided to do this with virtual reality. So this was in the office of ABT. We asked the architect to look at his facade, and this is what he saw. So in virtual real-time experience of the facade you would get. And he was able to make his choices, the right choices for him, but also for all the technical aspects that were involved, but also for the logistic aspects. And let's show me the results of this experience. And this is the facade from inside. The first slide I showed you, the facade from the outside. But I think the inside, it's an incredible building. If you are in Holland one time, you really should visit it, because it's beautiful on the inside and beautiful on the outside. And the facade really has a prominent role in this whole building. And what also was quite nice is that we managed to reduce the number of truckloads for the precast concrete facade elements by half. So there were 200 truckloads less needed as in the original design. So also quite nice sustainable benefits also. So that was my second project. I have one to go. And I saved this one for last because it also took the longest from the start to the delivery. We started with this one. First of all, it's about the Forum in Groningen. And it's a really big building in the center of Groningen. As you can see in the environment, it's like some kind of big rock is landed in the center of Groningen. And it has really specific characteristics. We started in 2007 with the design team. And first, ABT was approached for the structural engineering. But soon after, we also were asked for all kinds of other engineering services. And also facade engineering and facade consultancy was one of them. And the really important one, because the facade is really expressing the concept of the building. It's, I was told it's meant to be a monolithic design. And that means that any disturbance and disruption of the facade has to be avoided. And it's quite complex in a way, because it's such a big building, and it turned out to be later that it's also in an area where we have earthquakes in the Netherlands. So that made it extra complicated. But in the beginning, we didn't know that. So we just started with the design. My colleague Marco van der Ploeg, as far as I know, not related to Chris, but they have the same last name. So, but he's a consultant and a design lead at ABT. And he took up this challenge with his design team. And he told me two things about the project. The first one he told me is, okay, when you want to design a facade, which you want to have no detail, you better start detailing, and you better do it well, because it's really crucial to the result of it. And the second one is, he told me that all the decisions and all the choices they had to make in the design stage, the concept of the building and the concept of the facade was leading in the choices they made. So that was two rules Marco told me they start with in this project, and they continue it till the day of the delivery. Oh, I have to go one slide back, actually. Yes. What also was important were three main topics in the design. And the first one is the structural concept, because the structural concept and the facade design are really strongly related to each other. And it all has to go with prevent all these distortion and disruption in the facade. So it was a very important topic. The second one was that the facade is designed to deform. and that's different than many other facades do. And the third one, I already told you what Marco told me about detailing, but keep your focus on details. So that were the main topics for the design. Here you see the companies that were involved in the process, but also on the left side, you see how the creation of the shape of the building, and also the creation of the facade happened. And it was a really awkward plot, and they kind of used the shape of the plot to shape the building. And this is the way the architect did it. So, and the shape was translated in this structural concept. On the left, you can see two concrete cores, and they are connected with a steel bridge structure. And it's very important because of this connection, you can avoid dilatations on the cores. So we don't have to make these dilatation joints where the cores meet the steel structure. And it was also very important in 2012 when the earthquake problems occur. Of course, the structure had to be reinforced at some points, at quite some points, but the concept was strong enough for itself that we didn't have to change the concept. And on the right, you see a seismic analysis, which colleagues of ours, ABT Vosmaer, made, on all the different layers and all the different zones in the building. And adjustments were made, but the structural concept was that strong that it could be maintained in a project, but which was really helpful in the designing of the facade. So, step 2 was, okay, if we have this structure and we know what it does, and you see that it has really limited tolerances in the right sketch. The max tolerances, it's bending like 25 millimeters at the most. So yeah, that was also a starting point for the facade. So we made a choice for a unitized system, and all the horizontal lines are functioning like a laundry line. So the unitized system is hung on these lines. And it functions like more or less like a snake skin. So every element is able to move a bit, but it's not disrupting the image of the facade. So that was, and you can see it in the lower picture on the left. You see these joints of the facade, and that's a space in which it can move a bit, upwards, left, downwards, all the same. We have two types of openings in the facade. The upper one, the single panes, are called the shooting holes, schietgaten in Nederlands. And on the lower picture, you see a fragment of what they call the keyhole, which was the facade of the atrium. And another special feature in this is that the facades are not in a 90-degree angle related to the central axis. And since they are also not in a vertical angle, they have also an angle to the vertical axis, they are not rectangular, the openings, but they have a wedge shape. And in this picture, you see what the concept of that was. So we have these rectangular boxes, and they start with the central axis, and the openings are shaped around these boxes. So this is how the wedge shape occurs. And we really consisted on this principle, as you can see, even when facade surfaces rotated. So this was really consistently applied on all openings. I talked to you earlier for the focus on detail, and what was quite remarkable was that in the different design stages, the concept of the details hardly changed. Of course, because of seismic analysis, a few changes were necessary, as for instance, the bonding of the structural glazing. It's a bit different as in the DD phase. And also the brackets to attach the system to the structure, they're much heavier than they were in the DD phase. But in the end, it was all a complete flush detailing over all the facade. So the natural stone is really flush with the outer line of the glass pane. And you see it in the complete facade. So after 12 years of engineering, this is the result. And for the time when it was engineered, it was really advanced engineering, and we were really proud of the result. So I think we really managed to realize a high-end facade on this project. Okay, I guess I'm running out of time a bit. So I have 2 slides to show. Because we have these 20 minutes, I have to make choices, and I really want to show you 2 projects. The first of those 2 is the Boijmans van Beuningen Depot, in which we were assigned and responsible for the facade design. And the second one is Crystal Houses, in which we also played a key role in the facade consultancy. Maybe you could see it as a cliffhanger for next time, as we hopefully can meet in person. And yeah, so I would like to thank you all for your attention and your time, and hopefully we see you next time at AVT. Thank you.
We're now supposed to talk to him as if he's real.
Yeah.
And well, 2 cliffhanger projects which are super prominent. Man, you have to show them. I have a question. You're now a facade specialist. You're a specialist engineer. How do you start first? Is it the detail or is it the concept?
Wow, that's a good one. I would say depends on the project, and it depends really on how strong the concept must be. And sometimes a good detailing also can lead to a strong concept. So, yeah. Can give you one answer on this, Ulrich. Sorry.
It's a real solicitor's answer.
Yeah.
Huh? It depends.
I like the one with the earthquake engineering, and in a certain way we were involved in similar things. Who defined for you how heavy the earthquake can be, and from when onwards you allow your facade to fail? Because these were long discussions we had. There are impact rates and all that, because it can be heavy. So how is that in the Netherlands defined when you do these kind of work?
Oh, this is going to be an interesting answer.
Yeah. We do really have earthquakes within the area of Groningen, and it's really a problem within the Netherlands because a lot of damage is done. But they are not that heavy as you can see in some different countries when you see buildings completely collapse and stuff. So I'm not a seismic specialist, but we do have within AVT. Okay. And I should ask them. I can't give you the right answer because it's not my experience.
All good.
But it's a new experience for the Netherlands, which is actually a huge swamp. And now you have this earthquake situation because of the gas. And,
I'm extremely surprised about that. Because, I mean, we had these issues in Turkey, obviously, and did something in Panama.
Entirely different story.
But that is probably more heavy. Great projects. Congratulations.
Thank you.
Thank you.
And now we have to make a digital flip because Dominique Vosmaer is going to present from the same location, so they switch the computer. Dominique Vosmaer, former student of mine, our team in Delft, studied building technology, master building technology, worked as a facade consultant at Bureau Heppold, and is a classmate of Joop Heuvels, who also did his master thesis with us. And at some point after 12 years, they decided to develop their own company in the Netherlands, which is called Frontwise. And I saw others looking at the webpage and feeling like, damn, this is really next generation. So Dominique, the floor is yours if this digital flip works.
Wow.
Here you go.
Yep. Warm welcome.
Thank you very much, Ulrich, for this introduction. And thank you very much for inviting me here. So today I would like to talk about the future of facades. And I would like to focus specifically on the circular facade economy and how we think we can get there. But first I will introduce Frontwise and talk a little bit about our work. Then we'll go into the future. And we'll finally talk about how to get there and what we can all do to get there. So who are we? We are Frontwise Facades. About 2 years ago, Joop and I decided to combine our facade engineering experience and our passion for the circular economy to set up our own company after having worked for 12 years for different facade engineering teams. Björn Heppelt, myself, and Arab is where Joop used to work. So, so with Frontwise, we now are an independent facade consultancy. We focus on complex and high-rise projects. And with every project, we strive to search for the most circular and sustainable facade solution. We do the traditional facade engineering as you're used to. So we provide engineering services to architects, developers, and clients during tender stage all the way up to completion. But we do a variety of projects. We also do feasibility studies for circular and sustainable facade solutions. And we support policymakers in all facade-related topics. And today I would like to focus on those feasibility studies and supporting policymakers. So the municipality of Amsterdam asked us to help them in developing the building envelope. The building envelope is something that they reach out with during a land tender in their land tendering system. So Amsterdam has about 70% owns about 70% of the land in Amsterdam, and has the opportunity to actually set higher targets when they tender their land. So, and they are aware that building to national regulations doesn't really, doesn't give you a quality standard, but it's really just a minimum requirement. So what we did, we helped them, we developed a guideline, which is called the Assisting Informed Design Guideline. And in this guideline, we talk about circularity, energy efficiency, biodiversity, heat island effect, etc. And this helps urban designers to understand that the ambitions that they have and the policy that they make, that it actually really has consequences for the facades that are being built. And in this 8 guideline, we set achievable requirements for facades. Also, Amsterdam asked us how can we help urban designers in understanding and showing the project teams what they really want, what those ambitions really are. So we basically translated the information that we put in the 8 guideline to a circular tender tool. This circular tender tool really pushes developers and urban designers to talk together, to discuss what targets they are setting for their projects. And because this circular tender tool will be part of the contract between the urban designers and the developers in the tender stage, it really gives them, pushes them to commit to the targets that they set. Another project that we did is a feasibility study of extended producer responsibility. This was commissioned by the Dutch Facade Trade Associations. And the reason that they were looking into this is because extended producer responsibility is really will accelerate the circular economy in facades. And so we looked into this. So first, extended producer responsibility is something that happens in other industries. It's basically means that the supplier is responsible for not only supplying the product, but also the disposal of the product. So throughout the whole life cycle of the product. We looked at this from a technical and organizational perspective. And the other project teams, Copper 8 and Hout of Lawyers, looked at this from a legal and financial perspective. And as part of this project, we conducted around 50 interviews. I will elaborate a little bit more about the different service levels further on in this presentation. And lastly, a project that I wanted to talk about is what we did for the central government real estate agency. They basically have the largest portfolio of buildings in the Netherlands. And they have a building in Rijswijk, and this is already an experimental ground for MEP products. And they also wanted to make this an experimental ground for facade products. This basically means that they experiment with products in their facade, and if they are successful, they could apply them in other projects in their portfolio. So it is a very interesting location to sell your product actually for suppliers. So what we did here, we first started with discussing with Rijksvastgoedbedrijf, which is a Dutch translation for it, what they actually really wanted. And this resulted in 4 ambitions that we identified, which was biodiversity, energy efficiency, circularity, and climate adaptation. And within these focus themes, basically, we looked for innovative products. So we set out an innovation challenge. And all these innovations that we found, we collected them in an innovation book, which really showed the state of the art of innovative products in the industry, which were not all already available in the market, but were also really in their early prototyping stage. And then we developed a project brief. One of the focus themes is circularity. So in this project brief, we set out quite detailed what the circular approach should be for the design and for the dismantling of the project. And we are still actually involved in this project. We still give some support during the design stages now, which is very nice. Right, so let's go into the future. What you see here is the Dutch sustainability targets. And as you can see, there is an energy transition and a materials transition. These are basically a result of the Paris Climate Agreement. And if you look closely and you think about the solutions that we are looking for in this energy transition and this materials transition, you can see there's a bit of a contradiction. So in the energy transition, we try to have better insulation values, which generally means more materials, or triple glazing, more insulation, thicker insulation, more thermal breaks. And we try to generate more energy, which really means more solar panels in the facades. If you look at the materials transition, we actually are looking to use less materials. So how are we going to do that? How are we going to merge these two goals together? Our suggestion is the following. It's not really a goal, the material efficient design, it's a method. And with material efficient design, I'm talking about circular design, which I'm sure everybody knows about. And really the goal is an energy efficient building with a very high circular potential, which I will talk about later. So keep this in mind, this is important. So this method, what is it? It's basically going, from a linear economy to a circular economy. How are we going to do that? We have to maximize the circular potential of a product or a building or a facade. And what is the circular potential? Well, I've written it down here. It's the chance that a material or product is reused with the maximum residual value and minimum generation of waste and use of energy. So that means that if a supplier or someone tells you that they have a circular product, then you should ask them if he can, if he knows what the future is like. Is he a fortune teller? Because if he's not, he can never tell you that he has a circular product. He can tell you that he has a product with a very high circular potential, with a very high likelihood that it will be reused at high residual value after the usage phase. So a circular product does not exist. And still, we see everywhere in all marketing campaigns, my product is circular. So from now on, you can be more critical. Now, what about facades? This is all interesting for buildings and interesting for phones and for coffee cups and everything. But why do facades have such a big impact? We have in the Netherlands a Dutch calculation method, which calculates the environmental shadow costs for all materials in the building. And what you can see here is a result of a calculation from WE advisors. And it really shows an average of the results of a building, of the MPG calculations. And you can see that at the top, if you look at the top three, number one impact on the MPG is MEP, but a very good and important second are structure and skin. So it is very important. And if we look at the energy requirements, and we have to include solar panels in our facade, it will increase even more. So enough reason to talk about the material transition. What we see here is a graph. And on the vertical x, you see circularity. On the horizontal x, you see the time. The light blue line is showing the circularity, the circular potential for of facade, which is designed for disassembly. The yellow line shows the circular potential of secondary materials. The blue line, the dark blue line, shows the circular potential of a facade made of secondary materials and which is designed for disassembly. And then if we look at the end, you can see that if a product is designed with a circular contract, which means a financial commitment of the owner to actually reuse the product at the end of the life cycle at high residual value, then your circularity increases. If you don't have that contract, it dives back down. So we have an approach, a different approach to the design of the facade. To ensure that you have a circular design of your facade, you have to start at the end of your life cycle. You have to start your design not with your product design, but with your end-of-life strategy. And only then you talk about how are we going to do it? Who is the owner of the building? How are we going to organize maintenance? How are we going to organize finance? And only after that, you can start designing your facade. So what does this end-of-life strategy look like? It's basically a combination of questions you have to ask. What do you know about, for example, 2050? What is 2050 going to look like? Or maybe it's 2060, we don't know. So it will be a kind of guesstimate. So from an organizational perspective, think about who is going to disassemble my building. And after it's disassembled, who is going to store it? Where is it going to be stored? And when I have a pile of facade elements, who actually wants those facade elements? Or if I have a pile of dismantled facade elements with screws and glazing, triple glazing, double glazing, whatever, who really wants that of a certain size? So you can design design for disassembly, but if no one really wants it at the end of the life cycle, nothing's going to happen with it, and it's going to be downcycled. So from a technical perspective, what recycling techniques will there be? What dismantling techniques will there be? Because if companies, facade contractors, with their current systems will have to take back facade facades, they're not equipped to dismantle this, and definitely not a high value. So if a facade contractor now commits to dismantling 3 buildings, then in 20 years' time or in 30 years' time, he will have to deal with that huge amount of dismantling of facade elements. So we all have to make sure that that is actually a feasible, financial, interesting situation that they end up in. Then from a legal perspective, what will legislation do at the end of the life cycle? How will legislation change? What will be the required RC values? What will be the required MPG, for example? So the material, what will be the environmental impact that we have to commit to? And then what are the financial incentives for the involved parties? So what is the owner going to do with the materials if the facade contractor is taking over the materials? And how can these financial incentives, how can they be secured? So what you can see here is an example of this kind of this end-of-life strategy. And if we look at the, you can look at it from a process perspective, level of process, a product level and a material level. And if you look at the product level, you can say, yes, my facade element is demountable. And so what is the likelihood of the full reuse of a product in a facade? Well, actually, I think my facade element can be reused. But then if I look closer and I look at the glazing, I look at the aluminium, I look at the thermal brakes, at the rubbers, I look at the insulation, the waterproofing membranes, I look at the support structure, what really of those separate elements can be reused? A glazing with its interlayers, with its low E coatings, with its solar coatings, can you really reuse it in 30 years' time? I don't think so. I think we have to talk about recycling in that case. Or maybe someone has another idea, because I'm sure that the techniques of recycling and the techniques of upcycling and the techniques of dismantling will evolve a lot over 30 years. But we have to take it into account in our design, in our end-of-life strategy, because we really want to achieve that maximum circular potential of your facade. So now we have a rough idea of our end-of-life strategy, and I have to emphasize that the end-of-life strategy is a living document. So you set up your end-of-life strategy and you keep on filling it in. So it will change during your design stages. So in terms of ownership, because we now have decided, we have thought about what is going to, who is going to be the owner of the building, ideally to achieve that end-of-life strategy. Now we have to organize it. How are we going to organize? Who will be the owner of the facade? Who will be the owner of the building? And then we come back to the service levels that I talked about earlier. So we did this feasibility study of those service levels. The first service level is focuses on taking back and reusing materials from existing facades. So this is really focusing on this huge amount of materials which are not designed for disassembly. What are we going to do with it? The second service level focuses on focus on the consortium of suppliers, the certified suppliers. They supply certified products, and they can also take back those certified products. The second service level focuses on supplying, maintaining, and taking back products from one supplier. And service level 3 is facade as a service. So this is the supplier provides a service, doesn't provide a facade. And there's a difference in ownership here. So in the facade as a service, the owner is the facade contractor or the supplier of the product. But in the other service levels, it's a traditional construction where the building owner would be the owner. And I'm sure this is all in development, so I'm sure there will be different constructions here that we can find. But this is something that we have to decide on in our end-of-life strategy. Right, let's go to the next. And then finally, we can go on to the design. For the design of a circular facade, there are, of course, lots of options. And you can do it all the way through, or you can do a little bit. But a few important questions are, can you reduce the amount of materials in your design? Can you use bio-based products? Can you use secondary products? It's all to do with the trias materia. The backbone really of design, circular design, and design for disassembly. And in terms of, if you look at it from an organizational perspective, it's important to select materials and select products from suppliers who are willing to cooperate in a circular economy. So who are willing to cooperate in that ownership construction. So in that take back construction, because if you have a product which is maybe has, 50% recycled content, that may be nice, but if someone can't take it back, you're still put up with 40% non-recycled content. So what are you going to do with that? And also there may be an additional cost, because material passports are a very important item in the circular economy. If you don't use material passports in your buildings, we will end up in 30 years' time with a huge pile of facades, and nobody knows what's in it. And so in my view, material passports are a very important part of the circular design. And so if you have your end-of-life strategy, you can start designing your facade, and you can do that, as I said, a little bit with a little bit of circular potential and not so complex and not such a high financial impact by focusing on optimization. And if you go a step further, you can focus on material usage. And one step further is focusing on design for disassembly, and going all the way is really going for those circular contracts. And so what I want to say is every little bit helps. And then finally, I would like to finish up with what can we do? Circular design is really a method. It's not a goal. Everyone can do it. Everyone can adopt it in their design, in their facade engineering. And it's easy because you really just have to think differently. You have to think circular, not linear. You just have to start thinking about that end of the life cycle. And if the client doesn't have any sustainability goals on the project, think about what you can do. Nobody will say no to sustainability if it is for free. So I would just encourage everyone to lead and educate your team and your clients, because for every material, product and facade, there is a better and there's a worse option, and you can always go for the better option. And improving the circular potential of a project is always possible. Thank you.
You start.
Very impressive. Great presentation. Thank you for that. Interesting field. I mean, we all working in that field know how difficult it is to convince our clients to follow that path, right? There are all these beautiful concepts, and there is the reality we suffer on. When you speak about circular economy, you use the term economy. How is the situation in Netherlands? What is providing you with an infrastructure, rules, regulations to push this into the attention of your clients just by what you have in Netherlands specifically? That would be interesting for me.
Yeah, well, I think in the Netherlands we are quite far ahead. So everybody knows about circular economy. Everybody has their opinion. Everybody has really their own translation of what is circular economy and what is circularity in general. So I think everybody would like to hear about it. But I've been in projects, in tenders, where they really said, well, really, let's just start building to national regulations and then let's see how far we get. And yeah, although that's not really encouraging, it is how the world is, and it is it is how it is. So that's why I would like to encourage that even within budget, you can do better than worse. And if you just think about it and just make a decision to go left or right, you still do a little bit.
Yeah, Uli, we're joking about that probably the environment in Netherlands for this is good because by nature you guys are traders. So creating something where you trade after life a product and give it an additional value is probably something what belongs fabulous to your country.
I think I'd like to add to that. She's not talking about circularity.
No.
She's talking about circular economy, which we all know.
It's
The budget is also a driver. So this is a real translation into the budget issue, which is always an issue. So talking things green doesn't help, but you have to make them possible to finance.
Economy. Very good. Thank you so much.
Yeah, no, I can answer.
Oh, please.
Yes, come on.
So I think because what you see in facade engineering and in architecture, you see that there are so many ideas around the circular economy and circular design. But really, what we need to make sure is that we have to change the way we think in terms of the cost plan, so it's not only an island that we're working from, because what I've seen in the project that we're working on is it's really the system which is a problem in building projects. So the cost plan, how is the cost plan set up? Who decides what the budget is, and who decides that total cost of ownership is not really doesn't really affect the cost plan of a building. We need to change how that works, and we as facade engineers are not equipped to do that. But what we are equipped to do is to educate the teams and the cost consultants to show them that they have to think differently, so we can inspire them.
If people as ambitious as you are stick in that industry, it will happen. I press my thumbs. Very good.
Thank you.
Thank you for that.
Back to Frankfurt.
My pleasure to introduce the last, but not the least, or the other way, the last speaker of the day. It's Paul Denz from Priedemann Facade Lab, one of our young guns who makes us obviously extremely proud. Paul is leading our R&D division for longer. He looks young, he is young, but smart guy. And he will take you for a ride on adaptive facades, and it will be obvious a very interesting thinking and looking on things these people do. So enjoy.
Thank you very much. So last presentation of today, coming a little bit back to the loop between Priedemann and Delft, because I'm going to talk about a research project which also supports me in doing my PhD with Ulrich Knaack at TU Delft on smart textile skins. First of all, as head of R&D, I'm working with our Priedemann Facade Lab, our knowledge hub on facades, where we try to experience within our workspace novel facade systems, exchange ideas, show within our showroom in Berlin products, and we do the thinking, we do R&D, and the driver for this is that we aim for an active facade, so trying to bring things together, developing novel ideas, integrating technologies, new materials into the facade to enhance the performance of the facade, but also enhance the user comfort. I'm also a driver for this is the issue we all know, climate change, sustainability, and as you can see, the Intergovernmental Panel on Climate Change also will put in their next paper the issue of building environment, focusing on pushing this tool we have here. And as you know, building construction sums up to 50% of global resource consumption. I mean, more or less we talked about this today already. And also the energy demand within the European Union is summed up 40% from building construction. So there's a lot of things for us to tackle. And I want to show one project, as I mentioned today, within our R&D department where we're working on, which to some extent tries to find solutions for these, which is called Adaptex. So it's an adaptive textile. And we develop a system which is based on a shape memory alloy a rather small component that we, due to textile integration, can scale up into a higher, a bigger scale, a bigger surface, and then using the smart material within the textile structure to perform geometrical deformation that then results in the change of the density of these structures that then can be used within the building skin, for example, sun shading, ventilation, and so on. First of all, coming back to what is shape memory alloy. It's a alloy normally out of nickel and titane that can be developed in various materials as sheets, as wires, as springs. And the interesting thing about the shape memory alloy is the smartness of the material. So it actually reacts to thermal influences on the material. So when it heats up, it deforms into a trained geometry. And when it cools down and a force is applied, it moves back into its original state. So you're able to train these, the specific performance you need into the material. And the interesting thing is, therefore, you can use this as an actuator within the system. Then within Adaptex, we started since, as you already see, there are a lot of things coming together. We started with a design matrix where the various disciplines that collaborate in this project brought in all the requirements from the smart material, from the textile design and construction, from facade engineering, and also from architectural design, and creating this scheme, which then led to various first small-scale prototypes and designs, concepts how this textile facade system could be developed, and in 3 main schemes, pull, push, and rotate, that then were narrowed down into 2 main concepts, which is, we got on this side the Adaptex wave. As you can see, it's a continuous band of a textile band that is, due to the integration of the SMA, changing shape. And the next one is Adaptex mesh. It's a mesh textile, 2-layered mesh textile, that due to the integration of the SMA can move against each other, and by this change the density of the all-over structure. Going a little bit more into detail of these systems, in the next step we developed a first demonstrator 1 by 1 meter, where you can already see the evolvement. In Adaptex wave we have a main structure out of a steel rope net to which these bands are attached, and then you can see here in these lines there's the SMA that's interwoven into these textile bands, and then by the either the temperature from ambient temperature that applies to the SMA, or electrical current, you can run this system, and the SMA within the textile shortens, and by this is causing this deformation, as you can see here. So you have an interwoven wire that shortens, and by this is anticipating the textile surface to deform and close the all-over structure. The second design is Adaptex mesh, where you can see here you got 2 layers that move against each other. So within one of these layers there are thin SMA wires integrated, and once the same way as for wave, the temperature rises within the system, the SMA shortens and moves 1 layer against the other, which then changes the deformation, and the pattern, as you can see here, compared to the first design, is optimized also to counteract the moiré effect, so you can actually have also a nice visual appearance even when it moves. So you can see here, you have a glass fiber in the front for high reflection, and then a basalt mesh in the back, which moves smoothly between these 2 stages once the SMA is activated. We then did some simulations to also compare these to basic systems like a Venetian blind to anticipate and understand the shading effect of these systems in various orientations, and also compared to state-of-the-art systems. So you can see on the top a Venetian blind, a roller blind, or electrochromic glazing. And then in these radar charts where we looked into the view through the system, the lighting, the sun shading, glare protection, these issues to compare between standard systems and these developed systems, where you can see by the coverage that actually they perform quite well, also to compare to market-ready products. And then going into even more complex or individually designed or adaptive facades, you can also see that here both wave and mesh, by the coverage of this radar chart, actually perform quite good compared to also other build systems that are told to be adaptive or that interact with external stimuli. As I mentioned before, the SMA can be either run self-sufficiently as it reacts to temperature and can be trained and also individually customized. You can either run the system as on the top as a self-sufficient system where you have a change of the different stages, so the activation of the system around the temperature of, for example, 40 degrees, if you apply it as an external system, or if you apply it within a cavity at 60 or 70 degrees. Alternatively, you can also run it as an electrically controlled system, so you customize your SMA to be operated on a higher temperature, so it's not automatically activated by ambient temperature, and you apply an electric current to imply this temperature and activate the system. We then also looked into how to lay out a system for external application. So if we want to use it as a self-sufficient system, here, for example, the example of Abu Dhabi, if we want to use it outside, looking into what are actually the times of the year and the times of day we want the system to open and to close as a self-sufficient system which is not controlled by any automation system, simplifying the process and making maximum use of this smart material. As you can see, obviously, there is a kind of difficulty that, for example, if you use an SMA activated at 34 degrees, you have a nice amplitude between day and night. So you could say in, for example, public spaces where you want to shade during the day and you want ventilation during night, you can apply this very well. As mentioned before, we built first demonstrators 1 by 1 meter. They're currently under testing at the Fraunhofer Institute on Solar Energy Systems. So we do optical and calorimetric tests to verify the performance and the sun shading potential of these systems. We're also currently designing and building larger full-size demonstrators that will then be also tested in our outdoor facility in Berlin at the Priedemann Facade Lab. As you can see here, it's 2 facade units, 135 by 280, with an integrated mesh and wave system within a double skin facade because we want to run it self-sufficiently. And then the next step will be a further step to bring this, as mentioned before, with this climate charge into an outdoor application in extreme climate. So there we're collaborating with the German University of Technology in Oman to use their eco house where they're testing novel approaches for building construction in extreme climates. And we're applying mesh and wave on these external sun shading areas they're having right now to verify, on one hand side, the self-sufficient operation, but also compare it to the current metal sheet they're using as sun shading. That's already it. I think I was quite fast, but as last speaker, you try to wrap it up. I want to say thanks also to our partners and the funding scheme. As you can see, it's a quite big consortium as all these technologies need certain expertise. And with this, I want to thank you for your attention.
I haven't seen you presenting since a while. Impressive. There's a lot of change. I see him very regular on this PhD topics, and there we pretty much go into the details. Yeah. But when I see it now as a package, very well. Yep. Thank you. This is
Thank you, Paul.
really smart. Really getting these components to move. Huh?
Yeah.
And now
I mean, it's tricky because you envision that the SMA you get it to work however you want it, but as in reality, it's a bit more complex and you have to adjust the design, but that's...
Okay, and now the facade
I have a question to that. Can I ask
when can I get it? When?
Yeah? Can I ask one? Because I found it interesting that you explained that it can run on certain temperatures by themselves and that can be overridden with electrical things, because always in these kind of shading elements we have the wish that the end user can influence what is happening, right? Yeah. So is there a thinking how you can combine these self-controlled things by embedding the electrical thing at the same time that he can switch what is happening, or is it?
So there may be two approaches. So as you say, ideally we want to run it self-sufficiently, but then you can't override it. Yep. So you need to look into a specific typology where you say it's fine if you don't override it, like a semi-public space, or you combine it with counteractive SMA that you then run electrically, or you integrate it in a system that couldn't be moved separately. So the thing is interesting enough that generally whatever we develop, I got the feeling that there's also always a architectural or design possibility to play with it to actually achieve the performance you want it to have. You just need to maybe sometimes think a little bit around it, and then you can also make it happen the way you want it.
Thank you, Paul.
Here comes thinking skin. Huh? That's the
yeah.
point. Okay.
Yeah.
Exactly. Thanks for that.
Thank you so
now
much.
The idea is to have a communication. Jens, you have to come, and we need to get the... Oh, there they are, the Dutch colleagues to join us as well. And we briefed them in the beginning to pitch us, to give us beef.
Yeah.
And I asked this question already, so you had enough time to prepare yourself. So what's next? Next to your, say, Dominique, your individual trigger. What triggers you to change things?
What triggers me to change things? It's... Well, there are two things, really. I just really enjoy solving puzzles. So I just like a good puzzle. And the big puzzle is, well, as I said before, in my view, is we have a very high and ambitious target. And well, the way we're designing, producing, building, consuming at the moment is just not enough. Where we just have to change our way of thinking. We have to change our lives. So I take that impact.
I take that impact. Get a clear signal to me. Jens.
Yep.
What triggers me is the question. Well, I think what really drives me is curiosity, and many things are going on. In digitalization, I would say, is something quite recent that we hear, but I would say whatever comes, and there are many things in the interface between buildings and computation. That's something where I'm interested and want to push further.
Yeah. Gertjan.
What triggers me is that I read an article last week of the World Wildlife Fund that since 1970, 70% of wildlife population has decreased. And my personal trigger is to contribute to a better biodiversity in design. So that's really a personal trigger for me.
How would you do that in your designs? How would you convince, say, the architect of this glass bowl in Rotterdam to get biodiversity in his facade?
Yeah, in the metal they did, because on the roof terrace they
that's the roof. That's the roof. So that's the roof. But the facade itself, this shiny glass piece.
Yeah, a really good question. I think when we should start on this again, I really should think that I believe in every design there's room, there's space for opportunities. So it only asks a different way of thinking. So when we could have done this again, maybe the result would have been different in the end.
I hear this question of biodiversity of other places as well. It's really interesting to see. Paul, yours.
Maybe just there are new things. I mean, there are so many interesting possibilities, and on the other hand, so many things we need to do, I think, to get better and more energy and resource efficient. And on the other hand side, there are so many opportunities, also what we see in other fields. Like, for example, also with other techs, these kind of technologies are far more evolved in other fields. So I think we should just, or what drives me is just to try new things and bring new things into facade and building technology.
See him laughing. He loves it.
I love it, but I mean, what triggers you?
These people. Cool. This was a direct answer. This is very much emotional answer. So you get these people and you experience them and you see them. And I haven't seen him presenting since a year. Bang! Totally different story. Cool. Super impressive. But we wanted to be bitched. So what do you want to change, Dominique? What annoys you? What do you want to change?
I think what I found actually, and that's maybe also something to you, Ulrich, in the university, we focus on technical design, we focus on technical education. But what I find in real life is that the financial part, the logistic part, the legal part is at least so important as the technical bit. So I think that's something that we should change to educate our people in a little bit of everything.
I cannot agree more. You're right. Jens.
Well, I think we are slow, and at the same time, we have many concerns, I think, in the current developments. So maybe to think a bit more out of the box and to be a bit more brave in trying out things, that would be cool.
Yeah. Maybe not brave.
I don't know, but
maybe a bit more pushing.
Yeah, I could. Well, maybe I just took the wrong word.
You hold a PhD, man. You're super educated. Your voice counts.
Yeah.
Give it a point.
Yeah.
But you got my point, right?
Gertjan, what do you want to change? And finance is already done. Finance and administration is done. So something else.
Yeah. Now, what I want to change is the role of the facade engineer in the Dutch building industry. Because
that's a good one.
In the Netherlands, we have, for all engineering services, a consultant at the design table, but not for the facade. So I really want to change that.
Couldn't agree more.
Yeah, good point. Paul.
Well, there are so many things we discussed earlier, and I would say maybe also coming back to what I mentioned before is dare more, expect less. So dare to try more new things, and also maybe some things where you still see that there are some problems ahead, but at least it pushes you in a way that goes forward.
No, this is the corporate, everything is positive. No. What do you want to change?
And then expect less. So also accept failure.
Okay.
And accept failure within a higher collaboration between everybody involved.
So 80% perfect, but not 99% perfect. By a German engineer.
Exactly.
But it's the truth.
Yeah. And if everybody, like on a collaborative level, because if everybody is involved and everybody expects or accepts some failure from other parts, then it works out. But if you're just blaming people, it doesn't.
Yeah, there's quite differences between different countries in this respect, which brings it back to your point about the things we do not educate. When you blame me, we do not educate in university enough about, say, the legal aspects. Yeah, that's part of the business. Okay, I think time is now good. Cool. We two have to, you have to join me now here, and we two have to say thank you to all of you.
Yep.
And there's an applause of these 8 people.
Well done.
And we have to close the session by there I feel a kind of push, especially her and him. There are some aspects, but I would also challenge that generation to push us more.
Yeah.
So we have another 5 years, and then we hopefully pushed out.
Yeah. Kick us in
5 years?
5 years.
5 years.
5 years.
We have to announce new next things. The next session is going to be the NEXT Facade Summit on the 25th of March. On this channel. It's again digital, and it's going to be about thinking globally, building locally. Quite true.
Absolutely.
Quite true. And absolutely. I have to thank the Next Studio, which is supported by WICONA and Friends, which I'm supposed to say. And I have to say thank you, Christian, and thank you, Werner. Where is he? There, for organizing this kind of events and actually allowing us to invite our friends.
True.
To have, let's make them jealous, to have a beer now.
Yeah.
You're all tested.
We're all tested, and
That's
we
it.
all drink beer. So thanks for joining, and see you next time.
Next time.
Bye-bye.
Bye.
Discover NEXT, the studio for facades and design. NEXT is the platform for innovation in the field of building envelopes, for inspiration, information, and communication. Initiated by WICONA, with leading industry experts as NEXT partners. NEXT is a unique concept which is constantly evolving and bringing the future of cities to life.